And aloha, everybody. Hope you're doing well. Ready to do this Thursday, Friday thing, right? Why Thursday, Friday thing? Yeah, you work really hard on this warm up. You pay attention and learn how to get the area of a parallelogram and a triangle. And I will okay you taking tomorrow off. And if you do all your homework, get it done by 3 o'clock, I'll okay you taking Monday off. You can tell Mr. Williams I said so. Okay? All right, work hard. First off, copy it all down, then come back. You might need some help on these, so do as much as you can. And then when you come back, I'll show you how to do it. You can press pause, try it yourself, and then check your answers. Okay? All right, see you soon. And we're back, right? Hey, gotta love those numbers, those COVID numbers we're getting, right? 30 and 32, something like that, last couple of days. Yeah, we are talking, hey, we should be able to open up soon, huh? Yeah, I can't wait for that to happen. All right, again, you know the product goes on top. That's the answer to the multiplication problem. The sum goes on the bottom. What two numbers have a product of 36 and a sum of 12? 6 and 6, right? That's a perfect square. 6 times 6 is 36, and 6 plus 6 is 12. How about 3.6 and 4.9? How about 4 and 0.9? Right, 4 and 9/10. Right, when I add those, the decimal and the 4, you can't see it, but if it's not there, it belongs on the right. Right. Always remember, $4 is the same as $4.00. You can add a decimal after a whole number, just like you can put a 1 under a whole number to make it a fraction. Right. We don't do it unless we need to. Right. And it makes sense to do it here. So when I add, I follow the rule and make sure, real sure, that I line up the decimals. So if there's no decimal there, it's easy to put that 4 underneath the 9, right? But if I put the decimal there, then I know I got to line it up, and you put it in the right spot. Okay, so when I add 4.9, right, when I multiply 4 times 9 is 36, but I had to move the decimal. I didn't have to move it here at all. I had to move it one spot to pretend that was a whole number. So I have to go back one spot in my answer. That's why we get the 3.6. How about 36 hundredths and 1 and 5/10? What's going to work there? That's going to be 1 and 2/10 and 3/10. Again, you line up those decimals, I get the 1 and 5/10. When I multiply 3 dozen, 3 feet is 36 inches. 3 times 12 is 36. You bought 3 dozen donuts. You and I can share 36 donuts, right? 18 for me, 18 for you. Ooh, we both get tummy aches. We better find some more friends to share with. All right. So I had to move this over one spot to pretend it was 12, this over one spot to pretend it was a 3. So I have to go back. That's total 2 spots. I moved decimals. I have to go back 2 spots in my answer. That's how come that works. Okay. Did I stump you with this one? Mr. Daniel, you stumped me with that last one. Yeah. Now we're doing fractions, mixed numbers. What are we doing here? This is going to be 3 times 2 and 1/8, right? 3 plus 2 and 1/8 is going to be 5 1/8. 3 times 2 and 1/8, that's 3 2s is 6, 3/8, right? All right. When you write an expression, right, that means you're going to put all these together. How long is this line? It's x plus x plus x plus 1.2 plus x, but I'm going to put all of those x's together. How many do I have? 1, 2, 3, 4. That's the same as 4 times x, right? Plus 1.2. That's the simplified expression, right? We write 4x. Why not x4? They just like the number in front of the letter. They actually call that a coefficient. Coefficient. Say it out loud. Yeah, coefficient, right? You learn that because you use a lot in 7th and 8th grade, or in 8th grade anyway, right? All right, an A and a B and an A and a B and a 3.5. How about 2A plus 2B plus 3.5? 2A or 2B? That is the question. Yeah, that's Shakespeare's cousin, the math genius, right? All right, now what if I said that x was equal to 5 on this? How long would this line be? Well, you go 4 times 5 is 20. So it'd be 21.2. What if I said x was equal to 5 and b, or a, was equal to 5 and b was 10? You'd say 2 times 5 is 10. 2 times 10 is 20. 10 and 20 is 30 plus 3, 33.5. Okay. What if I said this line was 64 inches? Well, then you can write an equation. You would just write your expression equals 64, and then you could solve for x. Okay, we're not going to do all that. What are we doing here? 3 times 4.5. 3 times 4.5. I'm thinking that is one of those problems that really it's an advantage to do that generic rectangle. Put the 4.5 here, right? 3 fours is 12. 3 halves is 3 halves, which is 1 and 1/2. 12 and 1 1/2 equals 13.5. Okay, same idea here. When I have a whole number times a mixed number, I think it really makes it easy when you go 4 here, 6 and 2/5, because 4 times 6 is 24. 4 times 2/5 is 4 times 2 on top, 1 times 5 on the bottom, right? I don't know if you notice, you can put the 1 under the 4 and go do this, but the effect ends up being, since it's 1 times the bottom's going to stay the same. You're multiplying the whole number times the top. So 4 times 2 is 8 over 5. Now, 8 over 5 is bigger than a whole. If I use 5/5, I get another whole to make that 25. And if I use 5 of those 8, I have 3 left. Make sense? All right. Do the same thing here. 5, 2 and 3/4. 5 times 2 is 10. 5 times 3 is 15. And 15/4, that's way bigger than 1, huh? 15/4. Let's go ahead and divide the bottom into the top. 4 goes into 15 3 times. So that's 12. My remainder is going to go on top. My divisor on the bottom, right? So 3 and 3/4 and 10, 13 and 3/4. And another way to sort of just double check, when I estimate, this is going to be a little more than 4 times 6, a little more than 24, 25. This is going to be a little more than 3 times 12 or 12, 13.5. This is going to be a little less than, right? If I pretend that's 3, I got 5 times 3 is 15, but that's less than that, 13 3/4. Okay, good double check and good practice when you practice your estimating. Okay, just like when I estimate this, I have 6 and 2 and 3. That's about 11. I'm going to say it's about 12 because I got a bunch of pieces, right? So 6 and 3/8. Can I make this 8s? The 2 halves or 1 half is 4/8. So now I can just add them, right? I'm not even going to write them vertically like I always tell you to. 6 and 2 and 3 is 11. 3/8, 4/8, and 1/8 is 8/8. What was my estimate? Huh? Was it 12? All right. When I subtract here, I am going to write these vertically so I prevent myself from making a common mistake. There are no 7ths up there next to that 18. So I write 0 7ths, and then I know I got to go borrow. Now, don't put a 1 in front of that, because when you borrowed 1 whole, you didn't get 10 7ths. You got 7 7ths. 7 minus 2 is 5, and 17 minus 4 is 13. Now, another way of doing these when you have a whole number and you're subtracting a mixed number is add up. Okay, what do I mean? How many 7ths would it take to make that 5? Well, I need 7 7ths. I have 2. I need 5 more. So I'm saying 5 7ths makes that 5. And how many between 18 and 5? Well, 13. 5, right? That's one way of doing that. All right, these are the hardest problems you do in 6th grade. You are subtracting mixed numbers with unlike denominators, and you have to borrow. Even saying that stuff, right? So 5ths and 7ths, I'm going to 35ths. All right, and 2/5, I did 5 times 7, so I got to go 2 times 7. That's 14 35ths. 4 7ths, I did 7 times 5, so I go 5 times or 4 times 5, that's 20. And I can't take 20 away from 14, so I borrow. Now, don't put a 1 in front of that. I borrowed how many 35ths? 35, but I'm not subtracting 20 from 35. I had 14. I got 35 more. That's a total of 49. Now, 49 35ths minus 20 is 29 35ths, and 7 minus 4. If you got that, you get the cowbell. Okay, this cowbell is for the people who got that answer right. Plug your ears. Woohoo! Good job. You even get the A spinner on that one. Fidget spinner. Woohoo! Pretty cool, huh? All right, on to the next problems. Area. You know area of a rectangle is just how wide it is times how tall it is. The two sides of a rectangle work there. 7 times 12 is 84. And meter times meter is meter to the second power. It's 84 square meters, right? Remember, we're figuring out how many squares. This is 7 rows of 12, right? So I would have 84 little squares in there. Now, what about a parallelogram? You get all these diagonals and stuff. Well, since this line is parallel to that line, I can draw a line straight down here, get my scissors out, right? Cut off that triangle, slide it over here, and it will fit perfectly right in that little nook and cranny, right? So it's no longer here. Now it's over here. And what do? I got a rectangle. 12 times 7. It is also going to be 84. Okay, when they say the area of a parallelogram, the formula they give you is A, that's area, equals the length times the width. And they have the sort of fancy L, so it doesn't look like a 1. Length times the width. Okay, so the length times how long is it? Right, times how tall is it? Right. Now the key is you got to have that the two lines that make the right angle. Okay, you don't care about that 8.5 when we're getting the area of this. That's in there just to confuse you, or to get the perimeter if you need the perimeter. All right, you care about the 8.5, the perimeter, because that's all that's going around it, right? But the area, you care how tall it is, that's how wide. Okay. Now this one you're saying, but Miss Daniel, I have no idea how to do this one. Let's use some logic here. What if I made another one of those triangles, flipped it upside down, and put it right here? Now I have what? A rectangle. You know how to get the area of a rectangle. What part of that rectangle is this triangle? Give you a hint. I just cut it in half. The area of a triangle equals 1/2 times the base times the height. Remember, of means times. So 1/2 of the base times the height. Now, why do they use base and height for triangles and length and width for rectangles? I don't know. But if you find out, tell me, okay? Because it drives me nuts too. Okay. How wide is it times how tall it is, and then take half. Okay. You could see that. This triangle is half of that rectangle. Should have drawn it. Yeah. 12, 7. 12, 7. It's half. So 1/2 of 84 is 42. That's all you got to do. Okay. Now, the hard part is memorizing. How do I get the triangle again? So, again, I always say, go with what you know. You know how to get a rectangle. Can I make a triangle out of that rectangle? Yes. And what would the area of that triangle be? It would be half. So I can realize it's going to be half. Go with what you know. Parallel. Can I make this into a rectangle? Yeah. If I cut off this triangle and slid it over here, I made a rectangle. How wide is it? How tall is it? That's my, right? Go with what you know. Okay, so you're going to forget the formula for these things sometimes, but go with what you know and logic it out is what we say. Use your brain and think about it. And does that make sense? Okay, all right. Here we have a parallelogram. I don't know how to get there, parallelogram, but I know how to get to a rectangle. Can I make a rectangle? I'm going to chop off that triangle. I know that angle is the same as that angle. I know this is coming straight down. This is coming straight down. So if I slide this triangle over here, I have cut it off here, pasted it back on there. I've made a rectangle. It's 20 wide. It's 14 tall. 20 times 14 is like 2 times 14, 28. But I had another decimal, right? Move it over one spot. So 280 square centimeters. Okay, how about this triangle? Can you make it a rectangle? Yes, you can. By making 2 of these triangles and flipping one upside down, right? Now, if it was a square, That special kind of rectangle would be 8 times 8, 64. That is half the square. What's half of 64? Half of 64 is 32. Now check this out. I did the 8 times 8 first. What if I did 1/2 times 8 first? What's half of 8? 4. What's 4 times 8? 32. Doesn't matter which order when you're multiplying, right? Now what are we talking units here? Square meters. You got to put the units when you're doing area. All right. Oh my goodness. How do I make a rectangle out of this? Here's what you do. You can make another parallelogram just like that. Turn it upside down and put it right here. Right? This is the same as this. This is the same as this. This is the same as that, right? And you know the area of a parallelogram is how wide is it times how tall is it. Now, if you're having trouble with that, after you've made that parallelogram, now chop this triangle and bring it over here. And now we got rid of that, we put it here, we have a rectangle, right? You say that's not 30 anymore because you chopped that off. No, I glued it right back on over here, right? I glued it right back on. So it's still 30, it's 8. 8 times 30 is 240. Is that your answer? No. Why? Because that is the entire parallelogram, which was 2 triangles. Remember, I made another triangle and I glued it on there upside down to make the parallelogram. So I need to take half of that, right? And I said 224, it should be 240, right? Half of that, half of 240 is 120. And if you got this one, you definitely need a pat on the back, right? Okay, that does it. You got that right? Take tomorrow off. Sleep in. Wake up at pie time and see if there's a video available. All right? All right. Hope you did well. Have a good one, everybody. Aloha.